You paste a 2000 word document into an AI chatbot. It seems it can read the whole things fast, especially if you don't enable the thinking mode. Then it begins answering, one word after another. So you may ask, why can an LLM process thousands of input tokens quickly, but often generate only tens of tokens per second? For a standard autoregressive transformer LLMs, the answer comes down to two phrases: prefill and decode. During prefill, the model processes your prompt. The text is split into tokens. For example, explain why the sky is blue. Those tokens are already given. The model does not need to choose them one by one because the full prompt is known. Many token positions can be processed together using mask parallel computation. The casual mask still prevents each position from seeing future tokens, but the GPU can calculate many positions at the same time. This creates a large matrix multiplication, exactly the kind of work GPUs are built for. That is why prompt processing can be faster per token than generation, even though very long prompts can still create a noticeable delay before the first token appears. During prefill, the model also builds the KV cache. Inside each attention layer, the model calculates keys and values for the prompt tokens and saves them. Later, while generating the answer, it reuses them. Without KV cache, every decoding step would need to recompute the key and value representations for all earlier tokens. The cache stores those representations so the model can reuse them. It still has to compute the new tokens representations and run that token through every layer. So the cache removes repeated work, but it cannot remove the dependency between output tokens. After prefill, the model predicts the first token. To generate the second token, the first must already exist. Then both tokens are used to predict the third one. For example, the sky, then the sky appears blue. This stage called decode. Decode is sequential for each sequence. Every new token depends on what came before it. A 100 token answer requires roughly 100 generation steps. The KV cache makes each step cheaper, but the steps still happen one after another. There's also a hardware difference. During prefill, the GPU receives many tokens and gets a large amount of parallel work. During decode is different. Now GPU has a massive model but very little new input. Repeatedly moving model weights from GPU memories is often a major bottleneck. Moving KV cache data also becomes expensive. The GPU may be capable of enormous computation, but during decode, feeding that computation can become the harder problem. Imagine repeatedly moving an enormous collection of numerical data past the processors only to produce one new token. This also explains why batching helps. One request generating one token may not fully use the GPU, but many requests can be combined into one batch. This improves GPU utilization and total throughput. It doesn't mean every user gets the faster response when the server is busier. More traffic can still create queuing. Modern inference engines use continuous batching to add and remove requests between generation steps. Each conversation still generates sequentially. The server simply advances many conversations together. So when you use an LLM, you experience two different delays: prefill before the first token and decode between later tokens. Prefill usually contributes heavily to the wait before the answer begins. Decode largely determines how quickly the remaining tokens appear. A longer prompt can increase the first delay. A longer answer creates more sequential decode steps. Long prompts are not free, but the main contrast remains. Prefill offers parallel work across known tokens. Decode, however, follows an autoregressive chain. KV caching avoids recomputing the past, but it cannot remove the dependency between future tokens. The model can process many existing tokens together, but in ordinary autoregressive decoding, it discovers the future one token at a time. Techniques like speculative decoding can verify several candidate tokens together, but they do not eliminate the underlying autoregressive dependency. And that is why LLMs read fast but write slowly. Until the next video, good morning, good afternoon, and good evening. Bye.